Today I am going to teach Semiconductor Physics class 12 semiconductor topics, in which we have already learned about what is insulator, what is conductor, and what is metals, non-metals. In that only these topics come. Here semiconductors come from two words, semi and conductors. So let I will explain first how this word derived. Semi means half, and conductor means, as we already know, conductor is a metal which conduct electricity, and insulator are those metal which do not conduct electricity, and and semiconductor comes in between of that insulator and semiconductor. So conductor conduct electricity, and semi means half. This means it will conduct half. This will conduct half electricity, and this is only possible whenever we have to apply doping. And what is doping? Doping is doping. This concept come doping. Here doping means adding impurity to the main semiconductor. Impurities, it's like arsenic, phosphorus, and there are so many different kind of trivalent and pentavalent impurities. If we add in a semiconductor, then it will start conducting electricity. So how this doping will done? Let take a semiconductor. uh, Let us consider this is silicon, and we already know silicon, in the outermost shell it is only having 4 electrons. So if the electron is 4, so it is not able to conduct electricity, because this do not have any free electrons, because this is all if we see the structure of silicon, so it is like that: silicon, 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 silicon. So every its 4 electron is bonded with another silicon atom, so there is no free electron. So whenever we will apply another doping of arsenic or phosphorus, then it will create an extra electron or hole. It might be hole or maybe electron. This is happen due to adding of pentavalent impurities or trivalent impurities. So what is pentavalent impurities and what is trivalent impurities, now we will discuss. Pentavalent means penta, p comes from positive, and what is positive? Which is having positive charge? Electron does not have positive charge, so positive charge come from holes. We consider hole as a positive charge and electron is a negative charge. So in the trivalent impurities, electrons are the majority carrier. Here electrons are in free state, so it will move and conduct electricity. That's why this is called as trivalent semiconductor. And in the pentavalent semiconductor, holes are in the majority carriers and holes moves here and there, so it will conduct electricity. So due to both reasons this happen. Now we have two type of semiconductor, which is called extrinsic semiconductor, and another is intrinsic semiconductor. In extrinsic semiconductor, it is also having a two type, n type, p type. I have already explained what is n type and what is p type in the previous videos. And here the extrinsic semiconductor, it is a pure form of semiconductor, as I have shown in the silicon as I have already shown in the silicon, our structure, where you can see there is no free electron in the atom that can move. It's like this. Silicon is bonded with another silicon, and silicon is not only the atom which is bonded, which is intrinsic. We have also germanium. Now we are discussing about the germanium. As we already know, germanium has atomic number 32 and its electronic configuration in the outermost shell we have 4s2 electrons. So this will give extra 4 electron at the outermost shell, and this will provide germanium as this structure as same as silicon. So this germanium atom, one extra electron is bonded with here, one is here, one is here, one is here. So this will complete its outermost shell, and here is also. So this structure is also similar like that, this. So both are intrinsic semiconductor. And as I have tell you what is extrinsic semiconductor. In extrinsic, p-type we have holes as majority carriers, and n-type we have electrons as majority carriers. Now we will discuss how this n-type and p-type makes a semiconductor, because we are using MOSFET, transistor, BJT. BJT is also a transistor, and JFET. These all are semiconductors. Semiconductors comes and these are the components which are used in the semiconductor. So let's understand how semiconductor works. Let's take an example of PN junction diode. PN junction. So as we already know, what is junction? Junction is something where two wires combine. It's like if there is a two tracks, we don't have junctions. But if the both tracks combine, then at the combination point, this is junction. So junction is if the material is X and another material is Y, and the both material combine together and form X and Y, and this point is known as junction. This is junction. As we understand, junction is something which is X and Y, both material we have combined, and this point form as junction. So in the PN junction diodes is also work like same. As we know, p-type and n-type semiconductor, we will here connect. This is p-type and here is n-type semiconductor. Both semiconductor we have to connect, and here we apply a potential. Then what happens? This is positive, this is negative side of the battery. Battery, we already know how this works. In the positive side, electron flows. When electron go from here, it's move like this. An electron come here, and here it is a p side. We already know p is the more holes. Yeah, p is having more majority of holes, and n is having more majority of electrons. So what will happen? Electron will attract holes. Then holes moves here. This is holes. Holes moves here. Holes moves here. Because electron and holes wants to combine, because always positive and negative charge are going to attract each other. And here also the negative means we can take it as a positive charge. So negative will go here, and here the majority is electrons and here it is holes. So what will happen? Holes and electron will combine and both will goes away, and this will make as a junction, because here nothing is there, because all electron wants to move there or holes wants to move here, so there is nothing. We can consider it negligible electron at junction. So this can combine two material together, so we can make it as p-n junction diode. And this is a, and when there is nothing in the inside, then we will remove the battery connection. Since the material is connected together, then electron will leave their state and it will stay here. It is already p, this is already n. Electron now won't force at the edge. It can move here, 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 here. Maybe holes. Holes will be here. Let's make it at holes, 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 holes. Now we have successfully created a p-n junction diode. So we have understand how the p-n junction diode works and its working principle of p-n junction. And in the semiconductor, we have one more thing. p-n junction is a not only diode. We have different types of diodes. Diodes are known as, there are different diodes. Sometimes it is known as Zener diodes. We have more gun diode, and we have LED, LED that is known as light emitting diode, laser diode, etc. Because whenever we combine two different n-type and p-type material and it will fuse together, then it will make a diode, and this diode has different property for different uses. In the Zener diode, it is considered as most important diode and its function are very similar to the p-n junction diode, but the difference is, we can see in the diagram. The normal diagram of diode is p-n junction diode, it's like this, and for the Zener diode it's like this. So this stage says P, this is P side, this is N side. Here it is P side and N side. Here the N side is heavily doped, that's why this semiconductor properties changes. And we have gun diode, it's also different diodes. And in the LEDs it is also different, as we can see in our homes and every day in the life. LEDs are most used diode everywhere, and laser diodes we will use in remote and different applications. Now we have discussed what is p-n junction and how p-n junction combine together. Now if we connect one p-n junction and another p-n junction together, then this will form a BJT. I will show you how this will come. If we connect like the structure P, N and P, N, this P and P N can combine together and it's form a one point, and this is one and this is one. So this can be base, this is our base, one side will be collector and one side will be emitter. Base, collector, emitter. And this is the fused. As we have already discussed how the semiconductor works and how the diodes combine together and it will form a layer. This will help in a BJT, and BJT works like a switching device. How the switching device work? Whenever we will change the voltage in the base, this will depend P side and N side. Let me show in the diagram, it will easy to understand. This is the basic structure of BJT. This is base, collector, emitter. We have added a LED here. LED is known as light emitting diode. As you can see, this is LED is connected here, and in the collector we have applied a voltage that is 5 volt, and in the base has the full potential to control this LED will glow or not. Let's see how. If we don't apply any voltage, then there is no charges, there is no gate voltage, there is no base voltage. If there is no base voltage, then it will act as a intrinsic semiconductor. We have already learned what is extrinsic and intrinsic. This will be the intrinsic semiconductor, and intrinsic semiconductor is always works like insulator. So if there is insulating layer between the PN junction diode, then there is no switching operation will happen. So if we apply the voltage, this applied voltage will changes its property, and now it's become a conducting device, and this will turn on this path. And if this path is turned on, then the electron will start flow from collector to emitter. And this is very simplest example how switching operation is performed. Using this BJT, we have make inverters and different applications devices. So in the first lecture of semiconductor, we have understand what is semiconductor, how this terms comes from semiconducting devices, and its uses and its applications. So that's all for today. We will see in the next video.